exponential functions. These equations may look difficult at first, but here's the key. You want to look at the numerical parts of the equation and try to rewrite those numerical parts so that they all have the same base. So let's start by looking at 1/4. When I see the 4 in this equation and I see the 8 in this equation, the base that comes to mind is 2 because those are both powers of 2. So the 1/4 I'm going to rewrite as 1/2 squared. And in my rules for exponents, I know that was way back when, but you're going to need them in this lesson. My rules for exponents stated that if I have this situation where it's 1/2 to the second, that's the same as 2 to the negative 2. Remember that? Whenever we saw this negative exponent, that meant that we had to write 1/2 to the second to make it a positive exponent. Well, now we're just going back the other direction. And now let's look at the 8. The 8 is easier because the 8 I can rewrite simply as 2 to the third. So now I'm going to replace the 1/4 with 2 to the negative 2, and I'm going to replace the 8 with 2 to the third. So I'm going to have 2 to the negative 2 raised to the x power, and 2 to the third raised to the x minus 1 power. Another rule of exponents that we learned way back when is a power of a power, which is what we have going on here. Whenever you have these two exponents really close together like this, where we're doing a power of a power, in order to simplify it, you have to multiply the exponents. So here we're going to have to do negative 2 times x. On the right side, we're going to have to do 3 times this binomial. So in order to multiply a number by a binomial, that means you're going to have to, that's right, distribute. Okay, so let's do it. On the left, I'll have 2 to the negative 2x, and on the right, I'll have 2 to the 3x minus 3. Now we're almost there. We have a power of 2 on the left and a power of 2 on the right. So in order for the left and right side to be equal, that means my exponents have to be equal. So let's set them equal. Negative 2x equals 3x minus 3. Now it's just a matter of solving this two-step equation. I'll subtract 3x from both sides and get negative 5x equals negative 3. Divide by negative 5 on both sides, and I'll get x equals 3/5. Now, as with any equation, once you find your solution, you can always take that solution that you get for x and plug it back in to make sure that the left side does indeed equal the right side. Let's try another one. Remember, the key is to look at your number terms, your numerical terms here, your bases, and try to write them all as the same base. So I'm looking at a 2, a 16, and a 4, and I know that these are all powers of 2 again. So the 2 I'm going to leave alone. The 16 I'm going to rewrite as 2 to the 4th, and the 4 I'm going to rewrite as 2 to the 2nd. So I'll have 2 to the 4x times 2 to the 4th raised to the x plus 3, and 2 to the 2nd raised to the x minus 1. Now, just like we saw in the last problem, I've got a power of a power, right? My 2 to the 4th is being raised to a power. So what do I need to do with these two exponents? I need to multiply them. And in order to multiply a number by a binomial, I have to multiply that number times each term in the binomial. Same thing's going to happen here. This 2 is going to have to be multiplied by the x and by the negative 1. So let's do that. My 2 to the 4x is going to stay the same. In my next power, I'm going to distribute the 4, so I'm going to have 4x plus 12. Over here, I'm going to have to distribute that exponent of 2 to get 2x minus 2. All right, more exponent laws. Here I have two powers that I'm multiplying together that have the same base. Think back for a moment and see if you can remember what to do with these exponents. When I'm multiplying and the bases are the same, I have to add the exponents together. So what am I going to get if I add 4x to 4x plus 12? Well, I can only combine like terms, right, when I'm adding. So I'll get 8x plus 12. And on the right side, I still have 2 to the 2x minus 2. Now, just like we saw in the last problem, the bases are now the same, so in order for the left side to equal the right side, I have to make sure these exponents are equal. So I set them equal and solve. 8x plus 12 equals 2x minus 2. I'll subtract 2x from both sides, and I get 6x plus 12 equals negative 2. Subtract 12 from both sides. 6x equals negative 14. Divide both sides by 6. And x equals, I can simplify it to be negative 7 over 3. And as always, I could take this negative 7 over 3 and I could plug it back into each spot for x and make sure the left side equals the right side.